Good evening all. In today's class, we will be discussing about the chapter. It's called Kinematics. It is also called Kinematics. It is also called motion in a straight line. Okay. So in this chapter, there are various terminologies, various concepts, various topics, various formulas and all. This class is only about the important concept revision and formula revision. So I'm not going through all the basic terms and terminologies. Let us proceed ahead with the important topics. The first thing that we need to know in this chapter is first thing is distance. Okay, distance or path length covered. The length of the actual path covered by an object is called the distance. It is a scalar quantity and it can never be zero or negative during the motion of an object. Its SI unit is meter. That is distance, it's a scalar quantity. SI unit is meter. Let me denote distance as L. Okay, and also L cannot be zero or negative. Okay, the next thing that we need to learn is displacement. Displacement. It is the shortest distance between the initial and final positions of any object during motion. The displacement of an object in a given time can be, that I'm denoting the displacement as S or delta x. Okay, any one of these you can use. The displacement S can be positive, zero, or negative. Okay, and also the displacement formula for displacement can be written like, as this: S is equal to x2 minus x1. Okay, that is where x1 and x2 are the initial and final positions of an object. Initial and final positions of an object. Okay, also displacement is a vector quantity, whereas distance was a scalar quantity, right? Displacement is a vector quantity and its SI unit is also same as distance. SI unit is meter. Okay, the next thing that we need to learn about is speed. Okay, we can write here small topic: speed. The time rate of change of position of the object in any direction is called the speed of the object. We are denoting it as v. Okay, speed v is equal to distance traveled by time taken. Okay, it's a unit. SI unit of speed is meter per second. Okay, it is a scalar quantity. Speed is also scalar because it's related to distance. That's why, not displacement. It's a scalar quantity. Its dimensional formula is m raised to 0. There is no mass. There is length, that is at numerator, and denominator is time. So when it comes to numerator, it will be like this: m. This is the dimensional formula for speed. Okay, now we need to know about what is uniform speed. There is no particular equation for this. Just learn the term uniform speed. Okay, uniform speed is means if an object covers equal distances in equal intervals of time, then the speed is called uniform speed. There's another term also related: non-uniform speed. Non-uniform speed. Non-uniform speed means if an object covers unequal distances in equal intervals of time and vice versa. That is, equal distances in unequal intervals of time. Then its speed is called non-uniform speed or variable speed. Okay, that is, non-uniform speed is also called as variable speed. Okay, now we need to learn a new topic called average speed. Average speed. Regarding average speed, there are a lot of formulas. We're going to discuss it one by one. Average speed means the ratio of the total distance traveled by the object to the total time taken is called the average speed of the object. Okay, that is, average speed is same as speed. The equation is same, almost same, equal to total distance traveled by total time taken. Total time taken. Okay, this is one formula for average speed. One formula. Okay, let me write another formula for average speed. If a particle traverse distances, if the distances are in the question, if the distances are given like s1, s2, s3, okay, etc. Okay, with speeds, just taking the example in where distances denoted as s1, s2, s3, etc. with speeds v1, v2, v3, etc. Okay, then the average speed is what? Total distance travel. Total distance travel means s1 plus s2 plus s3 plus etc. divided by total time. What is time? Time is distance by speed, right? We know that distance is equal to speed into time. So time is most probably like distance by speed, right? So here what is the distance? The distance is denoted as s1 and the speed is denoted by v1. S1 by v1 plus s2 by v2 plus s3 by v3 plus etc. Okay, that's the formula for this. Okay, it's a very important formula, very important. I have seen questions with this particular formula. Okay, let us proceed to the next formula. If a particle travels, next condition, okay, if particle travels equal distances, equal distances, that is s1 equal to s2 equal to s, okay, with velocities, with velocities v1 and v2, then average speed is equal to 2 v1 v2 divided by v1 plus v2. Okay, you can note down this formula. Next point, I'm just writing down the formulas because these formulas are very important. How this came into being, if you want to study the derivation you can, but there is no need. These formulas are enough for this exam, that's why. Okay, another condition, if a particle travels with speeds v1, v2, v3, etc. during time intervals, during time intervals t1, t2, t3, etc., then average speed is equal to v1 t1 plus v2 t2 plus v3 t3 divided by t1 plus t2 plus t3 plus etc. Okay, plus etc. Okay, how this came into being, you can check the previous slide for the main equation. Okay, let us go to the next condition. The next condition is, if a particle travels with speeds v1 and v2 for equal time intervals. Here in this condition, the time intervals are equal time intervals, that is t1 equal to t2 equal to t. Then Average speed is equal to v1 plus v2 by 2. Okay. A rare special condition. You can special case. You can note it down. When a body travels equal distance with speeds v1 and v2, the average speed is the harmonic mean of two speeds. That is, average speed is equal to harmonic mean, hm. Hm means harmonic mean. Those who don't know the spelling can write it down. Harmonic mean, hm of two speeds. Those who have learned harmonic progression in sequences and series chapter, they know this. Okay, so we can write the equation as like this: 2 by v equal to 1 by v1 plus 1 by v2. Okay, very important formula. It's a very special case. Okay, very important. Okay, note it down. Let's move on to the next slide. The next slide, we're going to learn about instantaneous speed. Those who don't know the spelling, write it down. Instantaneous speed. When an object is traveling with variable speed, then its speed at a given instant of time is called its instantaneous speed. That is, I'm just denoting for the timing, I'm denoting it as is. Okay, since it's a very long name. The formula is equal to limit delta t tends to 0, delta s by delta t equal to ds by dt. This is of limits which will be learned in the upcoming classes. Okay, the next thing that we're going to learn is about velocity, because these all things are enough for knowing about speed. Now let's move on to velocity. The time rate of change of displacement of an object in a particular direction is called its velocity. That is, velocity is equal to displacement by time taken. Its SI unit is meter per second. Dimensional formula is same as speed, that is m raised to 0 L t raised to minus 1. It is a vector quantity. It has both magnitude and direction. It has magnitude and direction. Okay, the velocity of an object can be 0, positive, negative. Okay, next we need to know some terms. I'll write it at top. Some terms are, one of those terms are uniform velocity. Uniform velocity means that if an object undergoes equal displacements in equal intervals of time, then it is said to be moving with uniform velocity. Okay, the next one we need to know is non-uniform velocity. If an object undergoes unequal displacement in equal intervals of time, then it is said to be moving with a non-uniform or variable velocity. It is also called variable velocity. Okay, now let us learn about average velocity concepts. Most of the concepts of average velocity and average speeds are intertwined, which means it's almost same. So just know the basic definition of average velocity, and what all you studied for average speeds, you can apply the same logic here. Average velocity. So what is average velocity? Average velocity means nothing. It's nothing. Simple equation. Average velocity is equal to total displacement by total times. Not a very big deal. Okay. The next thing that we need to know is instantaneous velocity. Same equation, similar to, just small difference. Because instead of distance, it's displacement. That's it. Yes, instantaneous IV. Instantaneous velocity is equal to limit delta t tends to 0 delta x by delta t, where delta x means what? Displacement. I have told you s or delta x, which is equal to dx by dt. Now a very small important concept we need to know. It has been asked in various exams like aaiatc, JEE means JEE advanced scheme, NEET, RRB, NTRO, IB, many exams. Relative velocity. This topic is also important in the quantitative aptitude sections of many competitive exams. Relative velocity. What is this relative velocity? Relative velocity of one object with respect to another object is the time rate of relative position of one object with respect to another object. That is, relative velocity, and just denoting as RV. Relative velocity of object A with respect to object B is denoted as VAB. It is equal to VA minus VB. Okay. If it is in one-dimensional motion, we can treat vectors as scalars just by assigning the positive sign to one direction and negative sign to others. When two objects, now let us learn about special cases. When two objects, when two objects are moving in the same direction, are moving in same direction, that is, object A, it's moving in this direction, it's moving east or in right with the velocity VA. Object A, and object B is moving east with the velocity VB. That is, these two objects are moving in the same direction. Then the relative velocity is given by like this: VAB is equal to VA minus VB. Standard formula. Okay. Okay. Now let us know the equation for opposite direction. Next is opposite direction. VAB. Okay. C equal, that is a VAB means relative velocity. Always remember VAB, if it is given a question, it means relative velocity. That is relative velocity of object A with respect to object B. Okay, VAB is given as VA plus VB. Okay, that is A is moving in this direction with the velocity VA. Okay, but B is moving the opposite direction, that is in west with the velocity VB. That means opposite direction case. Okay. Okay, so a special case, just know this formula. Okay, when two objects, when special case, special case. Okay, when two objects are moving at an angle theta, when two objects are moving at an angle theta, that is, the figure will be like this. Let's say this is the frame of reference O. Okay, object A is moving in this direction, like in this direction, and object B is moving this direction. Okay, so this is VB and this is like VA. They are moving at an angle theta. Okay, then we can do some derivations and all. No need to do all of that. Okay, just know the formula. In any case of the question, if you see a special case like this, remember this formula. It's quite big, but it's pretty easy. VAB is equal to root of squares and square roots you might have learned in 8th standard or 9th standard. VA square plus VB square minus 2VA VB cos theta. Okay, so this is one formula. And tan beta, there's one angle called beta. Okay, that is along the frame of reference. If we draw a point here, there is an angle called beta. Okay, suppose they're moving at an angle theta, and this we make an angle called beta which is at a point. Okay, I think that's no need to study. It's a very huge formula. It's very hard to remember. I haven't seen any questions with reference to beta. Okay, no need to study that. Just know the relative velocity equation. Okay, this is enough. Okay, so if in any cases when we solve most of the problems, if they're asking us to find this particular angle called beta at that time, if it is necessary, I'll show the formula. Okay, now let us move on to the next concept, which is called acceleration. I think we can just explain it here. It's a very small topic. Okay, heading acceleration. What is acceleration? Acceleration is the rate of change of velocity with time. Is called acceleration. That is, acceleration A is equal to delta V by delta t. That is the change in velocity by time interval. SI unit. SI unit is meter per second square. Its dimensional formula is m raised to 0 L t raised to minus 2. Why t raised to minus 2? Because it's a square, right? Okay. It is a vector quantity. Vector quantity. Now we need to know about positive acceleration, negative acceleration, and zero acceleration. Okay, I'll just write the terms here. Okay, positive positive acceleration. Positive acceleration means velocity increasing with time, which means that velocity v increases with time. Okay, negative acceleration. Negative acceleration. Negative acceleration means velocity is decreasing with time. Velocity is decreasing with time. Okay, zero acceleration. Zero negative acceleration is also called retardation. All these terms you must know, because in the upcoming chapters all these terms are used, because we won't be saying negative acceleration, we will be saying retardation. So when we say retardation, it means negative acceleration. That's why I'm explaining it right here. Okay, next is zero acceleration. Zero acceleration. What happens in zero acceleration is nothing but velocity v is uniform. Okay, then we need to know about uniform acceleration. Uniform acceleration. Uniform acceleration means if an object is moving with uniform acceleration, it means that the change in velocity is equal for equal intervals of time. Okay. Next is non-uniform acceleration. Non-uniform acceleration. If an object is moving with non-uniform acceleration, it means that the change in velocity is unequal for equal intervals of time. Okay. The next one we need to know about is average acceleration. I'll write here. Average acceleration. Okay, if a particle is accelerated for a time t1 with acceleration a1, and for a time t2 with an acceleration t2 a2, then average acceleration is, which is denoted as AAV as suffix, equal to a1 t1 plus a2 t2 by t1 plus t2. Okay, I'll just rewrite the formula here. That is average acceleration a a v a v is equal to a1 t1 plus a2 t2 by e to t2 by t1 plus t2. Important formula. Okay. Then next we need to know about is instantaneous acceleration. Instantaneous acceleration we can written like this: a inst as Instagram as suffix. Okay. Equal to limit delta t tends to 0 delta v by delta t. This is equal to dv by dt. Okay. Next, one important term: uniform motion. Uniform motion. If an object is moving along the straight line, covers equal distance in equal intervals of time. Uniform motion means if an object which is moving in a straight line covers equal distance in equal intervals of time. Equal intervals of time. Okay. Then this is said to be uniform motion along a straight line. Okay. Uniform motion we can say along a straight line. Along a straight line. Okay. Now we need to know different graphs of motion, displacement, time graph. Okay. Now we are going to know about the different graphs of motion, the displacement time graph for different motion. Okay. There are a lot of graph for that. Let us move here. Okay, I'll just do one thing. Okay. Now let's continue. Okay. Different graphs of motion. Okay. Now, first of all, let us explain about displacement time graph for various condition. Displacement time graph. Okay. Let us show the displacement time graph for first condition. First condition is that for a stationary body, it is constant dt graph. That is, d will be on the y-axis, t will be on the x-axis, to be like constant like this. Okay. Second is, just study the graph by heart. That's the only way. Okay. Body moving with constant velocity. Constant velocity. dt graph will be like this, since it's constant velocity. Third one, body moving with constant acceleration. Constant acceleration. The dt graph will be like this. D will make a parabolic shape like this. Okay. The next one, fourth one. Fourth one is body moving with a constant retardation. That is negative acceleration. I only will be telling negative acceleration here for this chapter only. From moving forward, retardation term will only be used. For constant retardation, the graph will be like this. D and T will be like this. Okay. Next one. Next one is body moving with fifth one, right? Fifth one. Body moving with infinite velocity. Infinite velocity, but such motion of a body is never possible. It's a special case. Special cases can be asked because it's very rare. Okay, the displacement time graph will be like this. Okay, d, t. Let's say infinite velocity, we have 2 points A and B. Okay, graph will be like dotted lines. Okay, like this. And there is a note we need to say. Note. It's a very simple thing. V equal to ds by dt. What does this mean? That is, the slope of displacement time graph gives what? Velocity. This is a very important time asked in many exams. Gives velocity. Okay. The next thing we're going to learn about the different graphs of motion for velocity time graph. Velocity time graph. Okay, so let us move to the first condition. First condition is constant velocity. Constant velocity. The Vt graph will be like this. Vt. Okay. Constant velocity. It will be constant. Simple. Next is let me check one thing. Okay, 13. Okay. Okay. Next is what? Constant acceleration having zero velocity. Constant acceleration with zero initial velocity. The reason I am drawing these graphs and explaining is because in question, which of these graphs represent constant acceleration with zero initial velocity? Four options will be given, one will be true only. Okay, the velocity time graph will be like this. Vt. Okay, next one, third one. Body moving with constant retardation and its initial velocity is not zero. This we can write like this: constant retardation, that is negative acceleration, constant retardation with initial velocity we are representing as u. We will learn soon. Initial velocity will be representing as u. U is not equal to 0. Okay, the graph will be like this. V and t. Let's say we have 2 points A and B. Since retardation, it will be like this. Because u is not equal to 0, that is u can be anywhere but here. That is, it can from here and reduce, it can from here reduce. So I took a particular random point in velocity part, that is A, and pointed to B. That's it. The next one, fourth one, moving with constant retardation with zero initial velocity. That is same simple case, constant retardation when u is equal to 0. Graph will be like this. This is 0, right? 0. This is V and this is T. Be like this. That's it. Okay. I'll just clear this. Okay. Next one is the fifth condition, right? Yeah, fifth condition. Fifth condition means increasing acceleration. Moving with increasing acceleration. How will the velocity time graph be? Velocity time graph. It will be like this. Increasing, like a parabola. Increasing parabola. Sixth one, with decreasing acceleration. Decreasing acceleration. It will be decreasing like this. Velocity time graph like this. Okay. Okay. One note point to be noted. A is equal to dv by dt. Same as before. What is it? The slope of vt graph, velocity time graph, gives average acceleration. Okay. Now let us move on to the last topic for graphs, which is acceleration time graph. I'll just clear this bar. Third one, acceleration time graph. Okay. First condition, when object is moving with constant acceleration. The acceleration time graph will be like this. A t will be like constant. Second one, object is moving with constant increasing acceleration. Don't think of constant there, but there's a point called constant acceleration is keeping on increasing. Okay, don't be confused with constant there. AT graph will be like this. AT keep on increasing. Third one, object is moving with constant decreasing acceleration. Constant decreasing acceleration. AT, like this. Okay, like this. These are the graphs for These are the different graphs of motion for AT graph, VT graph, and ST graph. Okay. Now let us move on to the next topic. Equations of uniformly accelerated motion, also known as equations of motion. The very much important part of the chapter. Okay. I have told you before, we are denoting initial velocity as u, right? Initial velocity as u. When a body starts with velocity, it's called initial velocity. Okay. U. After time t, its velocity changes to after a time t, its velocity changes to v, which is called the final velocity. Okay. If the uniform acceleration is a, okay, so v is the final velocity. If the uniform acceleration is a is the uniform acceleration, and the distance traveled in time t is s. S is denoted as distance traveled in time t. Then some following relations are obtained, which are called equations of uniformly accelerated motion. Then those following relations are: first one, v is equal to u plus at. Okay. Second one, s is equal to ut plus half at square. Third one, v square is equal to u square plus 2as. Okay, these are the three important equations. A special equation, fourth one, which has been asked in many aaiatc exam as well as jeemains and advanced. The distance traveled in nth second, Sn. Sn means distance traveled in nth second. Sn equal to u plus a by 2 into 2n minus 1. What is it? U plus a by 2 into 2n minus 1. Okay. Also a special equation, if a body moves with uniform acceleration and velocity changes from u to v in a time interval, velocity is changing from u to v in a time interval, then the velocity at the midpoint of its path is given by v mid is given by root of u square plus v square by 2, a special equation. Okay, that is velocity at midpoint of a path when a body is moving with uniform acceleration and its velocity is changing from u to v. Okay, v mid. Note down all these equations. Okay, I don't have new slide, I'm just going to clear this. Okay. Now we are going to learn about the questions pertaining to the topic non-uniformly accelerated motion. Non-uniformly accelerated motion. When acceleration of particle is not constant, then the motion is called non-uniformly accelerated motion. For one-dimensional motion, v equal to limit delta t tends to 0, delta s by delta t equal to ds by dt. We know this, right? Also, a equal to limit delta t tends to 0, delta v by delta t, which is equal to dv by dt, which is again equal to v into dv by ds, which is equal to d square s by dt square. That is, acceleration is second differential of displacement, which is first differential of velocity. Okay. Here, delta s is displacement in time, delta v is velocity in time, delta t, and a is instantaneous acceleration. Okay, here a is instantaneous acceleration, delta v is velocity in time, delta t is time interval, delta s is displacement in time. In component form, we can write average instantaneous acceleration as like this: a is equal to ax I cap plus ay plus ay j cap plus az k cap. Okay, where ax is equal to dvx by dt, ay equal to dvy by dt, az equal to dvz by dt. Okay, note on this. Now we need to learn the last topic of this chapter: motion under gravity. Motion under gravity. Okay, if an object is free falling under gravity, when during free fall, initial velocity u equal to 0, equation of motion becomes v is equal to u plus gt. Okay, second one, h is equal to ut plus half gt square. Third one, v square is equal to u square plus 2gh. Instead of s, it will be noted as h, that is height. Okay, if an object is thrown upward, g is replaced by negative g in about 3 occasions, because we know that gravity is always downwards. So eventually acceleration becomes negative. That is the tradition. So minus g is equated in these equations. In cases of an object which is thrown upward, at that time in these equations g will be changed to minus g. Okay, these equations, not the relative concept. Okay, now we need to know some basic equations in this motion under gravity. Time taken to reach the maximum height. Time taken to reach maximum height. I have seen many questions based on like what is the time taken to reach maximum height. Like sometimes the initial velocity will be given, time will be given, or the height will be given. We need to find the time. In that case, the time is given by these two equations. Ta, it is equal to u by g, or if in case the height is given, total height is given, root of 2h by g. Or an equation. So the equation to find the time taken to reach maximum height, that is t is equal to u by g, or root of 2h by g. The total root, whole root of 2h by g. Okay. The next one is maximum height reached by the body. Body h max equal to u square by 2g. Maximum height reached by the body h max is equal to u square by 2g. Okay, then a very special formula. The theory part is like quite big. I think it's a bit better to explain in the next slide. Okay, I'll just remove this. Okay, another case. A ball is dropped from a building of height h. Okay, let's say this is the building. Okay, this building height h. Okay, uh, okay, this is the ball. Okay, this is the ball. It is dropped from a building of height h, and it reaches after t seconds on earth. Okay, t seconds on earth. From the same building, if two balls are thrown, one upward and one other downwards, with same velocity u and v, with same velocity u. Okay, let's say this is one condition with t seconds. Another condition is that we have a ball with building with height h, and if two balls are drawn, okay, one is like this, the sorry, one is like one will be like this, one of the ball will be coming downwards with the velocity u, another one will be going up and then coming with the velocity u. Okay, going up with velocity u. They reach the earth's surface after t1 and t2 seconds. Here first ball reaches at after t1 seconds and second ball reaches after t2 seconds. Okay, then what is the total time? Total time is given by t is equal to root of t1 t2. This is a special question. I think we will be discussing a question based on this formula. At that time, you will clearly understand. I'm just giving an equation for this. Okay, that is, we have a building of height h when two balls are dropped. Okay, one is dropped like downwards at the top of the building, like from with the same velocity u, and other I just uh, throwed it upward and then it fell the ground with the same velocity. Okay, that is, the first ball will reach the earth's surface at a time after time t1, and the second ball will reach the earth's surface after time t2. Okay, then what's the total time? T is given by root of t1 t2. Okay, one more point to be noted, just hear it out. When a body is dropped freely from the top of the tower and another body is projected horizontally from the same point, both will reach the ground at the same time. Okay, there will be a question based on that during our discussion class. We'll explain it briefly. Okay, so this is all regarding motion in a straight line, that is kinematics. Hope you all understand the class, and this concept can be useful for exams like aaiatc, jeemains, advanced, bits srm, vit, and many other competitive exams like rrb, ssc, and all. Okay, hope you all understood the class, and we will be discussing with practice problems in the next class. Thank you and have a nice day.